All right, guys, I'm back. We're going to start with conditional statements. We just finished up with truth tables, so this goes in our next sequence of logic. So remember, this is the logic unit, so it seems a little not math related, but you'll see the context in geometry when we get to the proofs. So let's start with your notes on the conditional statement. It's a statement that can be written in if-then form. And there's an abbreviation for that, and it's called the if P, then Q. So we draw a little arrow, and how we read it is if P, then Q, or we say that P implies Q. So the hypothesis is the phrase immediately following the word P. If. That's your P part, sorry. A hypothesis is the phrase immediately following the word if, and the conclusion is the phrase immediately following the word then. So when we take a look at an example, it says, if you live in Nashville, then you live in Tennessee. So my hypothesis would be, if you live in Nashville. If you live in Nashville. And your conclusion is then you live in Tennessee. And these are pretty easy, just identifying the if-then statement. So again, if is my hypothesis, and then is my conclusion. So go ahead and pause the video and finish your examples. You can go ahead and write your examples in the book, and then we'll come back out and I'll go over those with you. All right, so for example 2, you should have gotten their hypothesis is that the sum of the measures of two angles is 90 degrees. And your conclusion is they are complementary angles. Number 3, a quadrilateral is a square would be your hypothesis, and it has 4 right angles would be the conclusion. So the tricky part is, how do you write a conditional statement? So we're taking this broad statement, and now we're going to turn it into the form if-then. So if you take a look, I'm not going to write these out, but you can pause and write them out for you. That way the video won't take as long. So number 4, it says an obtuse angle has a measure greater than 90. So we don't have an if-then statement, but we can see that it kind of implies it. So what I'm going to say is that if an angle is obtuse, then it has a measure greater than 90 degrees. If an angle is obtuse, then it has a measure greater than 90 degrees. And I don't want to change this form. You know, an obtuse angle has a measure greater than 90 degrees. So that's when I turn it, if an angle is obtuse. So number 5, all numbers divisible by 4 are also divisible by 2. So we have 2 parts to this. And I'm going to say, if all numbers are divisible by 4, then they are also divisible by 2. Go ahead and pause it and see if you can do number 6 and 7 on your own. So number 6, I would say, if states are on the East Coast, then they border the Atlantic Ocean. Number 7, I would say, if it is Valentine's Day, then it is in February. And number 8, if numbers only have 2 factors, no, I'm sorry. If a number is prime, then it only has 2 factors, 1 in itself. So if a number is prime, then it only has 2 factors, 1 in itself. Okay, so that should finish out writing those conditional statements. Now we have different types of conditional. So if you have, remember the conditional statement is if P then Q. So now you have 3 other things that these conditional statements can do. The inverse is formed by negating the hypothesis and conclusion. So the symbolic form, how we look at that is, if not P, then not Q. So remember, my conditional statement is if P, then Q, right? Here's my conditional statement. So inverse is if not P, then not Q. The converse is we're going to flip them. Now I'm going to say it's formed by, I don't think the right word is flipping here, is by switching the hypothesis and the conclusion. So my symbolic form now is going to be if Q If Q, then P. So I just turned them. Okay? And then my contrapositive is formed by negating and switching. So now it's going to be if not Q, then not P. Okay? So let's take a look at the examples together. It says if it is Saturday, then there is no school. So here's my P statement, and my Q statement. So there's my hypothesis and my conclusion. So the inverse would read, if it is not Saturday, then there is school. If it is not Saturday, then there is school. Notice, it's no school. So to negate no, you got to make it a true statement. So if it is Saturday, then there is school. If it is not Saturday, then there is school. Now, is that true? If it is not Saturday, then there is school. No, that is not true. Because there's Sunday. Sunday, we also don't have school. So the truth value there is false. And you would say Sunday. The converse to that statement would be, if there is no school, then it is Saturday. If there is no school, then it is Saturday. And the truth value to that is also false because it could be Sunday. Okay? Your contrapositive would say, if there is school, then it is not Saturday. If there is school, then it is not Saturday. And my truth value there is going to be true. That absolutely could be true. Okay, so that's how we do that. So go ahead and practice on that one. And when you come back, I will read you those statements. Go ahead and pause it so you can practice. All right, so let's do number 2 together. So I'm going to read you these answers. The inverse here for number 2 should be, if the product of two numbers is even, then both numbers must be even. And your truth value is false. 4 times 7 equals 28. That's just one example. Your converse would read, if two numbers are odd, then their product is odd. And the truth value is that's true. And that last one, the contrapositive, would read, if two numbers are even, then their product is even. And the truth value there is true. Okay? So see how we negate that. Negating doesn't necessarily mean no, but I've changed the word from odd to even. That's how we negate it. Okay? All right. And then the next part is a biconditional statement. So a biconditional statement is the conjunction of a conditional and its converse. Conjunction of a conditional and its converse. Okay, so now we read this as P if and only if Q. So both statements now must be true. So biconditional statements are true when both conditional and converse are true. Okay? So both of your statements here must be true. So given the biconditional statement below, write both the conditional and the converse. And then we're going to determine the truth value. So there's not, when you're practicing these logic statements, they're not necessarily always true. So number 1, two angles are supplementary if and only if the sum of their measures is 180. So your conditional statement here would be, if two angles are supplementary, then the sum of their measures is 180 degrees. If two angles are supplementary, then the sum of their measures is 180 degrees. The converse would be, if the sum of the two angles measures is 180, then they are supplementary. And the truth value here is true. Both of these statements are true. So go ahead and practice writing these statements up until number 4. Okay? So I'll go ahead and we'll go over number 2 with you. So you should have had a chance to do that, pausing the video. And your conditional statement would be, if I wear my snow boots, then it snows. The converse would be, if it snows, then I wear my snow boots. And obviously that's false. The conditional statement is false. You don't, just because you're wearing snow boots does not mean it snows. Quinn wears rain boots all the time, even when it's not raining. So that's what number 2 looks like. Number 3, your conditional statement is if x squared equals 25, then x equals 5. And your converse would be if x equals 5, then x squared equals 25. And while it seems true, it's actually false. The conditional is false because x could also be a negative 5, and negative times a negative is also a positive 25. So that actually is false. Number 4, if I get 10% off, then I spent at least $15. And your converse would be if I spend at least $75, then I get 10% off. And your truth value there is true. Both of these are true. So that gives you some time to practice your conditional statements and your biconditional statements. If you have questions, of course, I would love for you to come and see me in tutoring. If not, take care. I'll see you in class.